notes, but he's not in the room. So I'm going to need somebody to back him up, at least till he shows up. Thank you, Carl. The laptop to share slides with everyone here is not on the usual screen, so we're not sure how to fix it. We've sent a message on Jabber, hoping one of them will show up. I think I'm going to run down to get the secretariat. I don't know what else to do.
Yeah, I think that's a good idea.
They're sending someone. Roman, do you know what to do to get from here to me to go?
That was too easy.
So apparently you're not reading the Jabber chat, where I said that 3 out of 3 engineers consulted suggested rebooting.
So is it just not broadcasting?
Well, no, we're seeing what's on the screen, but there's no mouse. You see?
I was being difficult.
The person who chaired in here yesterday said this never worked. Yeah, that's where we are.
So,
This thing know how to make that too, but it's probably got a battery in it. without a mouse, I don't have any idea what to do. That's the only app. That's all it's telling you. Don't want to log out to me to go. Do you?
Don't want to reboot. So this is what kiosk mode Pro, you think?
I have no.
So
It
like,
could be.
it's like full screen.
Yeah.
And so we think it's Linux.
But how do we get back to meeting?
Won't it auto restart?
I have no idea.
At this point, it can't make things worse.
Well, I'm just looking at you can't pull the battery.
No, exactly.
Oh, I see.
It's
do we
not
do
going to
it?
reboot.
Oh, well,
Did you run out?
I went to the rich.
Okay, so I was saying I can do that. So you did do it?
I did.
Okay, so they know. All right.
Well, the first line knows. Okay, so we're on the slides up.
I can't.
I mean, we could have everyone just to log into their version of IETF. Like you could broadcast the slides and everyone's just got to look at their laptop. Instead of reading it.
At least
Yeah, I mean, so we can.
better than wasting time.
Yeah, I think
Yeah.
that probably makes sense.
Right.
Yeah, everyone's got a laptop. Like we presented for folks.
Yep. All right, we're going to try and work around this problem while the Secretariat's getting someone in here to fix it. So if each of you, instead of using the on-site Meetico, will use the other one but muted, you'll at least be able to see slides. And while we're doing that, we'll get the slides up. The first thing, as always, was the minute taker. Alexis volunteered, but then he has not shown up yet. So Carl is pinch hitting till he does. I would say read the note well, but it's not on the screen. But as soon as you get your laptop up, it will be. So please do not contribute until you know what your rights and responsibilities are in the note well. In addition, code of conduct, please treat each other respectfully. And do you hit authorize? I think that was the problem.
That was an accidental back.
Oh, okay. So the agenda is posted. You can pull that up. The first things on the agenda were related to the documents that have made it to the ISG and the RFC editor. What do you do when it happens, when you get in this state? There's no
mouse. We can't bring it up. We don't know how to remove it like this.
You're not supposed to use that one, the Mexico one. You're supposed to, from your own laptop.
This is the one that's projecting over there. And I don't know what to do.
Oh, but I think
He's on the meeting code.
Yeah.
But you need to be on the. Go back to the agenda. Yeah, the IETF agenda. Go down to lamps. I still don't know how to do that. And click. Camera.
This one?
Got the lamp row.
Yep.
As a chair.
Should be.
Yep.
I'm getting them to come.
And when you do.
They're rad, no.
So you're, it doesn't matter. You're not using that, right? Yeah. Okay. Right. And go down to the agenda. Okay, you should be seeing the agenda on your screens now, right?
I don't know that it's shared.
Okay. We did that. Yeah. Yep. Yep. You're correct. I skipped a step.
Oh, right.
Yay.
All right, where's the next slide?
You have to go to the presentation. And there's next slide. So go to like 4 at this point.
All right.
All right. So there's the agenda. As you can see, it's super full. So this is super frustrating to have lost this time. But the first batch are those that are with the RC editor or the ISG. I'd like to just quickly to go down those and see if the authors have any changes to report with the back to the community. So if you can just go to the mic. Sean, is there anything with the document signing EKU document? No, okay, no status to share. The next one is the CMP algorithms document. Is Hendrik here? Yep. You had slides, right, for this one? Okay, so let's go to the folder and get those CMP slides.
So I can already start. On the CMP algorithms, there is nothing new. We spotted one typo that should be fixed at auth 48. With CMP updates, when drafting 4210 bis, we found out that there is some improvement to be done. In Appendix C of 4210, there was the old CRMF syntax used. So next slide, please. Next slide. Next slide. So yeah, this is a thing we spotted in 4210 while drafting the BISTRA document, that in Appendix C, this old 2511 syntax was used, and right now when we switch from encrypted values to envelope data, it would be more practical to make use of the updated 4211 syntax there, and therefore we propose to change this already in CMP updates, a section, I think it was 217, if I'm right, to make use of this extended syntax from 4211 already. So I wrote this also on the list, and Russ, you propose to do this also at auth 48 if this is agreed. Okay, great, thanks. Next slide, please. Regarding Lightweight CMP profile, so there was a new version submitted which addresses the comments from Roman. Thanks for that. Also, the GenArt and ArtArt reviews were addressed. I think 2 reviews are still open, but anyhow, the document is on the telechat at 1st of December. So yeah, we are happily waiting for the results. Yeah, what did we change? We added a section that points at 4210 bis and 60 712 bis activities, just to let the people know. And we extended the wording for extra certs to also contain trust anchor self-signed certificates for those devices who are not capable to store them, but are capable to store, for example, a hash on the public key or the hash of the certificate. And we added security consideration on that. Yeah, so that is it with those CMP related drafts in the IESG evaluation. Thanks. Any questions? Okay. Mask back on.
I'm getting it on my screen. Okay, the next one is 3709 BIS. I'm the person for that one, and there's no update to share with the working group. And then after that is NFT types for 5G, and again, no update to share, but Roman wants to say something. Go ahead.
I just want to double check because I envision when it goes to the telechat, this may come up. There is no more coordination to do with 3GPP on that document.
That is correct.
We have coordinated.
Yes, that is
Thank you.
correct. Okay, so then we're going to move to the security or the PKIX related drafts, and Hendrik rolled in the 4210, some of those topics, but there's more slides, I think. Is that right? Yep.
Yeah, as requested by IESG, we provided the 4210 bis and 6712 bis drafts after last IETF. Next slide, please. So regarding 4210 bis, I submitted a version 0, which is mainly the original RFC text updated to current XML versions. So this should be the original text. Version 01 includes the changes specified in CMP updates, and then a version 02 provided changes and some minor restructuring. The authors decided that would make it clearer while doing a first review of the whole document. So there is some key generation authority, extended key usage, which is now specified in a new section. There is this original PKI message, which was kind of, specified within some PKI management operation, and we pulled that out to the section 5113 in a separate section to properly introduce it. We removed any references to specific algorithms and pointed to CMP algorithms draft. Then we added additional references to the profiles in Appendix D and E, as well as to the lightweight CMP profiles in the section 5, where the messages are described. And we broadened the scope from human users also to devices and services. So just a wording issue. And there was one comment from IDNITS that we should switch from LDAP v2 to LDAP v3. Then right before this meeting, I submitted version 3 of the document where we fixed 2 remaining to-dos. One was on the specification of the old with new, new with old, and new with new certificates. We discussed this on the mailing list, and I added I updated the section accordingly. Then we also discussed on the mailing list that Appendix C could be, so the text in Appendix C could be shifted to sections, subsections in Section 5, where they belong from the content perspective. We did this change, and I'm uncertain whether I already deleted Appendix C or whether I added a to-do that this has to be deleted with the next version. Don't know.
You don't know.
I will find out. Then we added some to-dos in the text where we believe that support for chem keys is needed, as discussed in the interim meeting in September. This is mainly the last change that is needed for CMP 4210 bis. So, questions here? So next slide, please. Yeah, the proposals for supporting chem keys, the authors had some internal discussions, and there are mainly two topics. One is proof of procession in certificate requests. As discussed in the interim, Sean said that there is an ID in preparation on POP for chem key, so we are waiting for that and to figure out how this can be used in CMP. But actually there is already a proof of possession mechanism available in CMP that works out fine. That is called the indirect proof of possession, which is also used for encryption keys. Finally, the newly issued certificate is delivered in encrypted form, and the hash of the certificate is provided in the third conf message as a proof of private key possession. So this already works. Then CMP message protection using chem keys, at least for key update requests and revocation requests. The key to be updated or to be revoked should be used for message protection. If we then want to use it with chem keys, this could be used with a MAC-based protection at the cost of an additional round trip in advance to the PKI management operation, where a shared secret is established that is then used for the message protection. Next slide, please. So the idea mainly is if we have a chem key on the client side that the client sends in a general message, the type needs to be defined, and provides its chem certificate to the CMP server. The CMP server returns a cipher text from the chem encaps function, and the client then uses this shared secret from this response to do a MAC-based protection for the regular CMP request. So I've spotted there is some slight mistake on the slide. So the CMP server should have a server chem cert and a private chem key, not a signature certificate and signature key here. So that was from one additional slide we were discussing for situations where the server also not has a chem but a signature certificate. So this can be extended to also support signature keys on server side. Any comments on this sketch of a mechanism to support chem keys for message protection? If there is any feedback after the meeting, please post on the list. Any discussion is welcome, so it needs to be further specified in more detail, of course.
I'm not hearing anyone have concerns at this point with that mechanism. Mike?
Mike Ounsworth. At the risk of maybe reopening something from last time, we did solidly agree that it's worth waiting to get chem in and get chem in properly. That was a solid decision.
So the issue here is that we sent that updates document forward and the ISG asked for a consolidated document. So the question is, do we proceed with this and then do a chem if needed? And that's really the discussion here is do a proof of possession for chem keys. I'm sorry. But if this mechanism works, we won't have to do that. Does that make sense?
And I guess if this mechanism works, you mean if this mechanism doesn't generate an enormous amount of discussion or design or whatever.
Of course. But we owe the ISG a non-updates document, a BIS.
Okay, so mainly the change would be, of course, to add some text here and there. But from a technical point of view, if the indirect proof of possession is sufficient, this is already there. And this mechanism requires a new info type value to do this general message or to transfer the similar data in the general info field of the header.
Yeah, hey, it's Sean Turner. I guess I wonder, because I know that this is an indirect mechanism and it's the way it's been, it worked before. But in PKIX, in PKIX, there was a great history of letting 1,000 flowers bloom. Do we have to have one way? I mean, this is the point that Mike is making. Like, it's going to generate a bunch of discussion. Is this the one and only way we're going to do it? I don't know. This is the way that one of the indirect was one of the ways. There's a direct mechanism, right? Which I think you guys kind of looked on already. And there's a couple of other thoughts about it. So I'm just saying, great, but we can think about this, but like, it's not that we have to get this update done like tomorrow, right? All right. So
Please use the mic.
There's
There's a lot of remote people.
Yeah, there's some other stuff in flight. So I'm just saying it's great that we write this up and it's an option, but I'm not saying it's the option, and I don't want to like by not objecting now, right? Like, oh, we're good and we're running off and we're done. So there also might be more than one. So we just have to kind of figure that out.
And there's the OIDs here to inject another one later if that's the right answer.
Mike Ounsworth. I don't know if Panos is on the online, but I know Panos is going to push to adopt HPKE everywhere, and this is one of those places that I could see Panos wanting to, stop doing what you're doing before and let's all switch to HPKE.
So my advice at this point is to proceed with this mechanism in the document, and we can, if the other one gets mature, add it. And if not, we can do a small one-pager to say do that as well with this OID. Does anyone think that's the wrong way forward? Okay, I'm seeing thumbs up.
Okay, great. So we'll move forward specifying this. Okay, thanks. Next slide, please. So this is on 6712 BIS. So mainly it's the same approach with 4210 BIS, version 0 original RFC, version 1 updates from CMP updates, version 2 a minor review and some alignments, addressing IDNITs topics, nothing special here. And the document is quite stable. Thanks.
Okay, good, thank you. The next thing on the agenda was,
Sean?
Sean has more.
Sorry, I'm trying not to take the table out. Hi, this is Sean Turner. Just a minor note. We do have an 8446 BIS in flight, which is almost done. And so if this is another update, you should just point to the latest one. So they'll all kind of be, I mean, it's going to create a cluster, but like it's going to happen shortly. We'll find out about it tomorrow.
What does shortly mean?
I think Ecker thinks he's done.
Okay, so it really is.
So like the 8446 bis draft might get done before this one. So I think it's just better to point to the
Yeah,
latest one.
so might as well point to the ID at this point.
Yes, thank you.
Okay, thanks. Good.
Thank you. The next thing on the agenda, I did not get slides for, which is the PKCS12 support for PBMAC1. Is there anyone who wants to speak to that? Okay, skipping that agenda item. The next one is RC 7030 CSR attributes. Michael sent mail to the list about this. I'll just basically read it out. He has a conflict in this slot, so he's not in the room. There are still bugs in the examples of the internet draft. People have been very helpful about pointing them out to him. And so he knows he has work to do that he expects to do by the end of November. His co-authors have been very quiet, and so he's nudging them. And he'd like help from them fixing the examples. Okay. Anyone else wants to bring up about that? Okay, so we'll move on from there. The next one is I loaded the slides, so you may have to hit the little refresh thing for the lithium certificates. I think Jake is remote and will be presenting. Is that right? Not hearing you, Jake. No. I uploaded them while Hendrik was talking.
Hello, can everyone hear me?
Yes.
Wonderful. Okay, just waiting to see the slides on my end.
I do. Let's go to the tools. And there's a manage slide. There they are. There. So you click that.
Okay. Would you like me to try and take requests of the control of the slides?
If you click here, hit that button on the left side, you can control. Perfect. All right, you have control, I think.
Yes, thank you. Let me just test. Yeah, okay, wonderful. Okay. Okay, hello everyone. Yeah, despite my British accent, I am remote over here in the USA, so I hope you're all enjoying London. Okay, so just a quick update on the Internet X509 public key infrastructure algorithm identifiers for dilithium. We now have a repository for this within the LAMPS working group GitHub, and the link to the ID itself is there. Okay, so just to recap anyone who missed what this draft is about, the motivation is for the inclusion of the dilithium signature algorithm into X509 certificates. This is aimed at the description of pure certificates, in effect not composite or hybrid certificates. And you can kind of think of this as RFC 3 279 for NIST's PQ signature algorithms. So just a quick recap for the options, no parameters, the OIS will tell you everything you need to know. The key format, we'll talk a little bit more about this in this update. Octet string versus bit string, there's been a healthy discussion about these options. One signature algorithm per draft, and NIST is to define the OIDs. So these are currently in the draft as to be determined. So some updates since the last time, the public keys. If any of you have been following the discussion on this draft, I'm sure you're already aware, but the option moving forward is to go for an octet string that can be mapped to a bit string from RFC 5208. We're kind of following some precedent here from the SEPG org, in which we treat bit strings as octet strings identically, and obviously just do sensible padding. So we don't need to do any more wrapping or adding another layer for implementations that internally use octet strings, then they can continue to do so and use bit strings where the standard mandates it. As for private keys, we've changed the data structure and a call out to the one asymmetric key has been made. Some other updates, we did a hackathon for this over the weekend. This was just to work on some interop and consistency between the numerous drafts that are specifying encoding of dilithium keys. The outcome of this meeting, I think there is a small presentation about what we worked on and how it went. Thank you for everyone for attending that. We're going to continue to meet monthly and continue on the work we've kind of laid out there. Some key discussion points. I got a link at the bottom here. These are all being tracked in the issues section of the repository. There is one discussion point on deterministic versus randomized signing. There's a bit of some discussion within the forum on a new version of a hedged mode of dilithium, where they're kind of combining the idea of both some randomized signatures that are seeded by the message and the key alongside a source of randomness to try and facilitate those that may have a weak source of entropy, and also, consider some side channel analysis. So we're tracking that. We might expect to see something from the authors soon. There's also quite a discussion about hash and then sign. We're involved in an NCCOE effort, and we'll provide any findings that we have there. That's me and Panos. It's also been discussed within the CFRG working group, the LAMPS and the NIST alias. So we're watching that, and basically for this draft, unless something happens to change our minds, we're leaning towards following the DSA X509 from RFC 8410, which does not pre-hash, essentially. One last discussion point, public key encoded inside of the private key. This has also been some discussion in the working group where do we want to include the public key inside the private key, or do we want to include values that can facilitate the reconstruction of the public key if there are maybe perhaps lightweight modes that don't want to carry both the public and the private. So as I said, these issues are tracked on the GitHub. Feel free to use it or not. If you just want to message conventionally through the email list, I will just convert them to GitHub issues myself. So thank you everyone for the feedback so far, and I'm happy to take more from you guys. That's it. I see, so maybe someone has a question.
Yep, go ahead, Carl.
Carl Wallace. I have a question on the definition of the public key as an octet string. I know there's precedence for this, but it seems odd to give a definition of something as an octet string and then immediately in the prose say throw away the tag and the length. Why not delete that definition and just say you're encoding the public key directly into the bit string value?
Yeah, well, there has been a lot of back and forth on this, and there are a lot of people who have a strong opinion on which one to go for.
What's the strong opinion for having a definition that you don't use?
Yeah, so the argument is that it's the most natural structure for the public key. And so we've been encouraged to use the most natural data structure.
I think Carl's saying, okay, so you have an octet string, but when you're putting it into the certificate in the subject public key info, just take the octets and drop them into the bit string with 0 additional bits. So that one byte field will always be a 0. And then, so basically specify how to go from bit string to octet string, which has been in many specs over the years.
No, I'm not
Yeah.
really saying that. I'm saying the octet string never appears naturally anywhere. It's an artifact here because I guess we feel like we need to define it, but then we don't actually use it. And I'm just saying, because we had a number of things at the hackathon, folks encoding the 04 and not encoding the 04. And I get it where we have keys that are sequences, you have a structure, but here we don't. So just
Right.
say you're encoding it directly into the bit string, which seems the most natural to me, but
Okay.
I don't know. Anyway, that's my
I
2 cents.
understood your suggestion.
Yeah.
Okay.
Yeah, I agree. Unfortunately, that there are a lot of different opinions on which is the most natural. I'm just trying to please everyone.
Well, it's most natural, obviously. Mike, you're next in the queue.
So I'll just follow up Carl's point before I make the point I came up for. So during the hackathon, I think, Carl, if I'm not speaking ill of you, you sort of skimmed the draft and you saw octet string the definition. You said, great. And then you went on. And then like 2 hours later, you read the paragraph below it and were angry with your life. Right. Carl used the ASN1 modules, which are actually not descriptive unless you read the English text below it. And so that's sort of the problem here is if you take the ASN1 module as is, you're going to end up with the wrong encoding.
Maybe you could describe why having the octet string there. That's fine. Everyone understands what I'm saying.
Yeah.
We're all just sort of ignoring that.
All right. Carl's having a conversation with himself away from the mic. The point I came up here to do, can you go back to the private key, public key contains private key slide?
Oh, yes. Yeah. This one here.
Yes, public key encoded inside of private key. One different, but I think also deserves to be on this slide discussion point. There's been proposals for including the seed of the private key rather than the entire private key.
Yeah.
Is that worth discussing here? I mean, that's like sort of mega private key compression.
So I've kind of put that in the sub bullet point where it says, alternatively, we can include the values that allow reconstruction. That's what I was getting at then, the seed. Yeah, that has been proposed, and that is something we're considering. If people feel like it's a good idea, something that's useful, then yeah, absolutely, that is an option.
So that sounds to me like 3 different private key encodings that would need different structures. You have the private key and public key, or just the seed, right?
Yeah, it gets messy.
Right. Okay. Good.
Just
Yeah.
to highlight the draft UNI QSC keys -Kyber offers a way out of this with a choice, I believe. I don't know if that's where we want to go, but at least that should be part of the discussion. Okay, John?
Yeah, hi, it's John Gray. I was just wondering in the hash and sign case, so I guess EDDSA doesn't do that. I just think of the use cases like for HSMs, or if I want to send, my gigabyte file across a network. Is there going to be a plan for some other draft that addresses that kind of problem? Because it does definitely seem to be a practical problem that, is all over the place. So I'm not saying it has to be in this draft. I just think someone should be looking at it. So just wanted to point that out.
I agree with you there. I do see the use cases for both. Maybe something will come out of some of the discussions in the NCCOE as well about some plans there. But I do agree with you. There are strong use cases for both, and we need a solution for both.
Okay, thanks.
Hi, Jonathan Hamill. So I have to agree with Carl that I think that the byte string, like and not specifying octet strings, that's ASN.1, but the bytes that you get from the crypto library should be just directly put into the bit string. And this is because, like in one asymmetric key, the optional public key in there is a bit string. And then if you start specifying your key, your private key structure, then that uses a byte or an octet string for the public key, then it's not going to match with that one asymmetric key definition. And then you now need to do an encoding, this SecG encoding, to convert it from any other certificate into this octet string. So
Yeah, point taken, absolutely.
Okay. Seeing no more questions. Thank you, Jake.
Thank you.
Next is Kyber certificates. Don't believe I got slides, did I? Oh, yes, we did. Okay. No, that's CMS certificates. You put the wrong slides up.
Okay. We still love you.
So many drafts, so little time.
Yep.
It's only one slide, so, you know.
I don't know that we have it.
Yep.
Here it comes.
ASN1 algorithm identifiers for Kyber.
It's a mouthful.
509.
Well, all right, let me just start. So this draft was an individual draft and it got accepted as a working group draft. So we're still on OO. Basically, I owe an update. People are starting to use this stuff. I need to get off my butt and actually produce an output. And so this is just kind of a general status of what's coming next. This draft, I think, is a lot shorter than the dilithium ones because it's just about keys. It doesn't have to talk about signatures, and there's only one place to put it, so it's pretty simple. Next, it needs an update. So the initial version of this draft that was the individual draft kind of was like, we didn't know what NIST was going to pick. Well, they picked chem, they picked one. So we're kind of making it to be only about Kyber. So there's a whole bunch of text that's going to change that. As a result of that, we're going to put some ASN1 stuff in there with TBD for all the OIDs because we're going to wait for NIST to assign those. And then we want to make sure that we maintain alignment with this how to do it in CMS to make sure that we pick the right recipient info so that we're still doing key transport, right? We want to make sure we're aligned because otherwise the whole thing's not going to work. And then of course we have this issue with the private key format, whether we're going to include it, and we just talked about that. So I don't think we should really repeat the thing, repeat it. So it's basically the same issue. And that's really it.
Any questions for Sean? Okay, so you and Jake are going to coordinate, right? Because you said alignment with the.
Well, luckily we're authors on both drafts, co-authors on both drafts, and we've talked. So we're going to try to make sure that because I think the other draft is actually up for working group adoption, right?
It was we've done the call. We haven't done the.
Right. So my theory is once it gets adopted, then we're all in the same boat.
Hello, so Marco Johannissaaren. Just a little note about the private key thing. So of course in Kyber, it has the difference that you actually need the public key in order to do the decapsulation operation. So at least in CCA, which is why it's being standardized. So the private key will always have the public key. Yeah. And it would be better if it didn't have it twice. So a little optimization there perhaps.
They're big, it's just a little bit bigger.
Yeah. Right? So in dilithium, it only has the hash of the public key, and the public key in dilithium, the part and half of the public key is in the private key anyway, like they're all or a little bit 32 bytes. So having a key pair structure, it's all right. But you don't need the full public key to do a signature in Dilithium.
Great. Okay. All right. Thanks.
Okay, Carl, did you send any key attestations line? Okay, no update. We're skipping that one. All right, on to the next section, which is SMIME related documents. Alexi, do you want to just give a few words at the mic about header protection?
Yes, editors was slacking, so we're trying to get together next week to do update.
Okay, thank you. I'm unaware of anything to say about the end-to-end mail guidance. He just sent it to me?
No, he just joined the queue.
Oh, okay. Go ahead.
Hi there. So I released an update to the end-to-end mail guidance earlier this month that included concrete updates specifically to guidance around protection against some of the e-fail attacks that Marcus Brinkman and others described. There still remain a number of to-do items, and I would love to get more feedback from folks on that. I have not seen a lot of responses to it. So I'm continuing to update it with guidance that's coming in from sort of the academy, but I have not heard a lot from other implementers. I'm also continuing to shop it around to people who I know are working on mail user agents. Again,
so
happy to more.
In short, that's a try for review, right?
I would love to see people reviewing it. It's not ready for working group last call because there's still a bunch of to-do items in there. But yeah, I definitely want people to review it. If you work on a mail client or you use a mail client and you do anything with encrypted mail, please take a look at what's in there and provide feedback. Happy to take feedback in whatever form, mailing list, issue tracker, private mail. If you send me private mail, please include the title of the document in the mail. That makes it easier for me to find in my overwhelming mailbox. Thanks.
Thank you.
If people have questions now, I'm happy to respond now too.
Okay, now we need those CMS cover slides back.
Hi there. Can you hear me?
Yes, we hear you.
Yeah. So hello everybody. So that's just a short update of the Kyber in CMS draft RFC. So just next slide, please. Yeah, so the status of the RFC is the following. So we made some editorial changes thanks to the comments received from Carl and Michael. So we also definitely chose to use the key trans recipient info to communicate the algorithm info. We introduced a new type, which is a generic chem trans parameters type to store the algorithm parameters. And last change is about the algorithm limitations, because at the beginning the RFC was, let's say, algorithm agnostic, meaning that it was possible to use any chem algorithm. And in this new version, we limit the algorithm to Kyber and to the three security levels of Kyber, meaning Kyber 512, 768, and 1024. And we associate the corresponding KDF and wrapping algorithm to fit with the security level. So yes, that's it for the changes on this latest version. Next slide, please. And so yes, the open point, the open points that are still open. So yes, Sean already addressed that. There is an open point about the certificate convention, which fields have to be filled in the certificate. So there are some new OIDs to be defined, especially the IDChem trends OID and the Kyber OIDs. And another open question is about the limitation of the algorithm combination. Shall we limit the number of combinations to 3, 1 per security level, or should we leave it open to the implementers? That's maybe the last question, the last open point to be discussed pretty soon. So maybe that's it for this status. If you have any question, please let me know.
We have one person in line at the mic.
Hello there, Markku Johannissaarinen. So this is a kind of a forever issue that pops up. Is the key question of 192-bit security. So TLS doesn't have that. So and it showed up in various places like RISC-V instruction said we thought, do we really need key generation? The key expansion is really the complex bit for 192, but many hardware bits actually don't support it at all. So I would personally suggest dropping that and moving that to 256 bits. 192 is, especially AES 192 is a little bit obsolete. The SHA-384, for example, is everywhere. So I'm good with that. That's the NSA. So that's a suggestion.
Okay, thanks.
Okay, John?
Yeah, you probably already had this, and hopefully I'm not going back circular, but the chemtrans recipient info. I know there's another recipient info, and I guess it never gets used, and this is a new mechanism, so if it's not worthy of using other recipient info, I guess nothing is, but I guess that's been discussed in detail, or I guess just trying to figure out why chemtrans recipient info was used, because it kind of fits, but not perfectly. I guess nothing fits perfectly, but, or I guess I don't want to beat an old horse either, if it's already been discussed and decided that this is the way forward, but it just seems there was already extension mechanisms built into it to do this, to add new things. So why wasn't that done?
I think what he's proposing here on this slide is that identifier, ID chemtrans, is the other recipient info OID to say that's what's going on.
Oh, is that, okay, I didn't understand that.
Then
okay.
Others have proposed RSA chem uses key trans recipient info.
I guess, Mike, you're saying go back 2 slides.
I think you want one slide. Yeah.
Right.
Yeah, that's what I seen on the slide.
Ah, I see. I missed that. Thank you.
Okay, so yes, so your suggestion is to use over recipient info. That's
yeah. I'm just I guess wondering why. I guess is this the best of the 2 evils? I guess is that why it was chosen?
It is clear that that is the trade-off, right?
Okay.
There's 2 ways to wedge it in. This is one. And,
all right.
And the question is, and I think that's why it was on the discussion slide, is that the best trade-off?
Okay, that's fine then.
Okay. And sure, if you have an opinion, we should take that to the list. Sean.
Yeah, sure.
Hey, I'm Quinn Dangatnest. I agree with the person before John about the 192. However, with the Kyber chem, my vote would be to keep the Kyber 768. Maybe because that could be really good in performance and trade-off, security trade-off, and maybe a lot of people are going to use that. We just don't know yet. So with the AES, the story is very clear, but for the CAM, I'm not sure about that. So I think I would recommend to keep the CAM Kyber 768 in there.
Okay. Any response, Sean?
Hi, Sean Turner. We would like to avoid some of the problems we had with elliptic curve by providing too many choices. Less is probably more. I don't know how much less we want to go, but like letting us, let it. Picking 80 of these is going to be bad. So if it's 3 or 2, I think we're probably on the right magnitude of what we want. If it's any more, then I think waste of time.
Yeah, Marco again. So one thing that just popped into my mind. So Kyber at this lowest level, this has been some talk if the design team may actually drop that. So that's because it's based on current cryptanalytic results, it might not quite meet the 128-bit level. So that's something that NIST is considering of doing. So that would basically reassign the Kyber 7, the middle as the lowest level here. And I was just talking about the AES. So even in the AES-based Kyber variants, which are temporary, the specification makes it quite clear that those are not, the final version will use SHA-3 or shake only. Even those use internally AES-256. So AES specifically, the AES algorithm in bit 192-bit is not existent in Kyber.
That must be what Paz was about to say, because he sat back down. Okay. Queue's empty. All right. Thank you.
Thank you.
So the next draft is kind of a placeholder with us using Sphinx Plus with CMS. We have a placeholder document there. The working group adopted it. There was really nothing to discuss at this point. So please review it and send comments to the list. And the next set is under consideration. Is anyone going to speak to the binding for multi-auth document? I didn't get any slides for that. Ah, here comes Mike.
Moving about as fast as the elevators these days. Yeah, so there's this draft. It was presented in Philadelphia.
It's just too low for you.
There you go. Not my style. So we presented this draft in Philly. It hasn't changed since then. When we presented in Philly, we got a little bit of positive feedback. We got a lot of don't care, which actually wasn't surprising. And I'll kind of get to that. It came up for adoption and it was quiet. And then we got a bunch of objections. And we're kind of puzzled by that. The objections kind of fell into what we kind of considered two camps. One was things that kind of had been put into the draft, and maybe the objections were being made before the draft had been fully read or understood. Because we had done quite a bit of work into the second draft based on especially early comments. And then there were another set of comments that seemed to not understand what we were doing or to assume that it applied more broadly than we intended. So probably most of my comments here are going to be of that sort. I'm going to I'm going to kind of give this overview, and then if there are specific comments about the technical contents, Rebecca is there, and she's going to come up and address those. I don't know how much time we want to take about this.
I'd like to take enough to resolve, but whether we're going to adopt it or not.
Sure, but with Panos not here, I'm not sure that's going to happen.
He's not.
Yeah. So anyway, there's a transition scenario in the paper, but maybe it's not clear, or maybe it's not enough. One thing is that this extension is not a mimic of composite. Some of the questions seem to be, how are you going to address this, or how does this extension do these things? And it doesn't. It has a very limited function, which is defined in the draft. It's not meant to do any specific thing that any other mechanism does. So the basic premise is you have two independently issued and managed certs. If that's kind of not your scenario, this doesn't really apply. This is, however, what the DoD PKI, well, the DoD PKIs will be issuing. And so this is kind of the thing we're driving at. Some of the questions were like about how do the validity periods overlap, or revocation, things like that. Those are really important questions. This mechanism isn't meant to address that. This mechanism is meant to be used by DoD units that, I mean, it could be used by anyone, but specifically NSA is part of the DoD. I'm from the NSA Center for Cybersecurity Standards, if that wasn't clear. The DoD will has a lot of different types of devices, equipments. It will have a number of transition challenges. And so there will not be a one size fits all. So really the mechanism in the draft is a transition tool for use by people who are planning transitions. What it does is it allows units to create make before break transition scenarios. It allows them to do signing for the widest possible audience, perhaps on key distribution packages, things like that. I mean, things that a lot of people don't really care about. It allows, crucially, the plan is to allow for the movement from traditional cryptography certs to post-quantum cryptography certs. I've taken to say a pace, not as fast as possible, but as fast as makes sense for the transition that's planned. So some of the questions asked were good questions, but this mechanism isn't meant to address it at all, and it's not going to. That's not the purpose of it. The mechanism allows a relying party to understand that a PQC certificate and a traditional cryptography certificate, the private keys associated with them are held by the same entity. That's all it does. It's defined as a non-critical extension. You don't like it, you don't understand it, that's fine. And then there is an associated certificate signing request to get to give the CA the wherewithal to assert that the private keys are held by the same entity. And you're not in a scenario where this is extension is going to matter to you. You don't implement it. So we're kind of confused at why there's all of this kind of objection and piling on and whatnot. I understand there's a lot of questions, but most of the questions don't seem to apply. So I'm open to questions about that. If there are specific technical questions about the draft, I'll have Rebecca come up.
Mike Ellsworth. So hi. I feel awkward because I'm one of the people throwing you a lot of questions, and I'm not trying to shoot down your draft. I just, you know.
They're not bad questions. They're just not, the mechanism isn't meant to address them.
Yeah. So let me bring up two maybe that we can help drive to whether this is worth adopting or not by discussing here. The first one is someone pointed out on the list that there already is RFC 5697, which is the other certs extension. And its abstract says, some applications that associate state information with public key certificates can benefit from a way to link together a set of certificates that belong to the same end entity. It sounds exactly like the same problem statement
Go
your
to
draft
the
is
last
doing.
paragraph of the introduction.
Of which?
Of that.
Last paragraph of the introduction.
I'll steal your lead.
Sure, yeah.
It says that how the CA knows why and how to assert that extension is out of scope. Our mechanism brings it in scope.
Okay, well, so that's my next question. So to my reading, the major difference between 5697 and your cert binding is that you're adding a CSR mechanism, which is not here.
Okay, I don't think the mechanism is exactly the same, and that could be debated whether I don't think the extension is exactly the same, and it could be debated whether it should be or whether it should be something different.
Yeah,
but yeah, the key difference is the CSR. Yeah.
So
attribute.
So I'm here representing Entrust as a public CA. What scares me about this? Let me start the other way. What doesn't scare me about this? What I think in your draft is totally reasonable. And so we can start with what I think is totally reasonable.
Sure.
The CA issues 2 certs to someone. Here's your 2 certs. I've bound them. Great. Also, if it's coming from an RA, user already has a cert. The RA is sending in a second cert request, and the RA is saying these 2 certs should be bound. Great. Those 2 use cases I think are fine. The genericness of putting this in a CSR is, I think, what opens the Pandora's box for me. And as a public CA, if we receive a CSR, Entrust receives a CSR, and it's got a cert binding CSR attribute pointing to a DigiCert cert, what am I supposed to do with that? I can't copy it over into the cert without validating it because I'm a CA. I have to validate what's in the CSR. I also don't want to get into the business of Entrust having to figure out how to cross-validate certs that belong to other public CAs because that's going to be a nightmare. So in the context of public CAs, what am I supposed to do with a binding request attribute in a CSR? That's where the messiness, I think, explodes.
That's worth considering. I hadn't considered that. Rebecca, do you have an answer to that? Or okay.
And so it might be as simple as just saying if you're a public CA, don't allow these in CSRs, and then most of my objections would drop off.
Right. So, and I again, I mean, I don't expect this to be a general thing. I mean, this is really toward DoD use. So I would not expect that to be, you know, an issue, but that's worth considering. I mean, it's worth saying something about. Absolutely.
Yeah. So Tim Halbeck, DigiCert. I mean, you know, if you blindly copy stuff out at CSRs, and even if you validated it, if you expect that to go well for you 100% of the time, you probably shouldn't be involved in running a public CA. So I would think in the scenario that you mentioned, if you do get a request binding a certificate to an entity that's been validated by another organization, I would think you exit stage right immediately. Unless you have some agreement on how to do that with the other organization, or there's some compliance rules somehow that tell you how to do that. But I think that you just look at that CSR and you just reject it and say, you're asking me to bind to a cert I know nothing about.
Okay, and so that argument makes that completely out of scope for this IETF draft, but maybe CAB would have an opinion on that.
Yeah,
example.
potentially, or some other group that, you know, like it's a reasonable use case that you might actually want to bind a cert from 2 CAs, but if somebody wants to do that, I think they should write an RFC draft about how exactly that works or something like that, or, you know, some CAB forum rules, or somebody's got to explain how that works.
Right. certainly there would be a pre-arrangement. I mean,
Yeah.
if you expected that to succeed, you'd better pre-arrange it. Right?
Yeah.
I'm going to ask the completely naive question. Sorry, that's why I got this is Sean Turner, so I got in the queue.
And nobody believes you ask naive
Is this are you doing anything more than just validating that cert passed, like passed the math checks? Like, because I know like you're not sending in 2 CSRs, you're sending in a CSR that points to another certificate. So like when you're validating the other cert, you're requesting that just like the cert path validates back to a trust anchor.
Yeah.
That's it, right?
Yeah.
So then I'm kind of worried about what is this other thing that you guys think you need to do, that public CAs would need to do? Because all they're checking is that it's a valid certificate that hasn't been revoked.
Yes.
That's it, right?
Yeah.
So I'm kind of like, what else would you be validating? I'm just curious.
What I took from what Mike said was public CAs don't have lots of trust anchors hanging around from other public-facing CAs.
It's a good thing they're publicly available, right? In the truth source. So I mean, obviously, so I mean, the process would have to like change a little bit. So
they
I'm
are
totally
publicly
gonna do
available, but they're trust anchors, right? So
Right.
they have to be provisioned and all that jazz, right?
Right.
So that's the I mean, if you expected this to succeed, you would have you would prime that to make sure that that was the case.
Okay, fair enough. Yeah.
Right. So
But I mean, again,
I would not expect to release this CSR into the wild and just assume it
magically
would
work.
succeed.
Yeah. Okay.
This is part of a transition plan.
Yeah, so I mean, so there is an impetus there, and then the public CA was going to do is they would have to be configured with these other trust anchors, but the idea is they would get that, and then they would just use the paths to actually validate.
They would just validate.
And that's it.
They would just validate the service.
Okay, so it's not nearly as bad as I thought it was.
That Mike Ounsworth. Yeah, so I mean the point of the cert binding is it says this binding asserts that these 2 certs belong to the same entity or the private keys are held by the same entity, right? That's the assertion.
Well, right. So the CSR contains something that is signed by the other private key, right? So the evidence provided is that, and then the CSR is presumably signed by the PQC private key. So the evidence is that the person who holds the private key for the PQC cert also holds the private key for the ECC cert.
Right. So it sort of, I guess, gets into Tim's point of, do you trust the other CA's human validation processes and yada, yada, yada. And yeah, all right, I'll sit down now.
Yeah. It's worth that. It would be worth adding some words, I think, though, that situation would have to be prearranged. Yeah, sure.
Yeah.
There's a Tim ahead of me in the queue.
Okay.
Yeah, that would be me. I think Sean actually said most of what I was going to say, but yeah, the additional stuff that I'm thinking about that a public CA would have to do is around making sure it really is the same entity. I'm not sure I'm okay with just, and I mean, you can fix this by just changing what you're asserting. But I was thinking that you would do a better job of that than just, I've got a technical proof that this person controls that particular key. Because the difference between the identity that's associated with the key and who actually controls the key is subtle in some situations.
So, Tim, would it not be sufficient to say the subject and the subject alt names and the 2 certs have to be the same?
I would think that would be something you would want to do, but I would then additionally have the issue that if it's another organization, I have to know whether the way that I validate subject information is compatible, and B, that I actually trust the other company's validation well enough that I'm willing to sign off on it. But yes, in theory, mandating that these subjects are identical is a pretty reasonable thing to do.
Or even subject alt name and cert policy.
Yes.
Okay, go ahead.
Yeah, Rob Lee, Global Sign. I think a lot of it's already been said, but yeah, I was just gonna say that yeah, there's definitely a challenge, certainly in language, if not in practicality, between making sure that what the proposed RFC would say is being guaranteed versus what the certificate policy says. Particularly, domain validation means that there is really not a lot of guarantees on the entity that have been verified by the CA, who's then going to be signing this and saying, oh, well, there's a binding here, so it's the same person, when really what's being guaranteed is this the same person who has control over the domain. But as I say, I think it's already been said.
Okay, any other comments? Can I ask you guys to send a summary to the list to kick off Panos's response?
Yeah.
Thank you.
Okay.
All right, awesome. The next topic is composite keys and signatures, and I think Max is doing the presentation.
Good morning, everybody. Can you hear me?
Yes, we could hear you. We're getting the slides up, and then we'll pass control.
Thank you.
Yep.
It's very early here in Colorado, US. So good morning, everybody, and thank you for being here, and thank you for the opportunity to talk about this. So today we're going to present on the composite crypto, some updates on that, and the report from the hackathon results. So yeah, perfect. So just very quickly, what is composite? Composite crypto is just a mechanism to combine keys and signatures by using the same data structures that we already support, like the subject public key info, just a sequence of that. So we worked on the explicit combination that this working group really stressed the importance of to guide the PKI architects in their choice for the combination. And we actually removed the OR paradigm from the current draft. So the validation policy for composite crypto only requires that all signatures validate correctly. However, sometimes when it comes to composite crypto, so we discussed several use cases, right, for migration across different type of algorithms, like for forward-looking type of properties whenever you don't have confidence in the algorithms, or as a migration tool to provide backward compatibility across newer devices that might try to use the new algorithms, and you might want to also have their support for the older algorithms together without renouncing to the overall security. But these are not the only use cases. So think about composite crypto as whenever you don't have all the properties that you require from an algorithm, you have the possibility to combine with a different one, right? So I want to make a very extreme example of this use case. For example, let's try to think about let's start from the consideration that, although X509, provides all the needed data structures, for crypto agility, we know that things are more complex when it comes to real deployments, right? There's many characteristics of the algorithms, the memory that is used, the type of operation, the the sizes that really is killing us right now, for access network databases, so many different type of uses. And in our specific case, where we have a very large deployment of devices, cryptography is becoming a critical component, right, in the device lifecycle, especially in the consideration that this type of problem, we were very lucky with RSA being so long-lived, probably will not be that lucky with the new set of algorithms. So we really want to be able to build in processes that allows us to repeat this process in a cost-effective manner. So there are many considerations that we need to do. So do we have enough memories in our really deployed devices? Will our protocol supports it not just on paper but on the real deployments? Addressing this, so this is just another example. Let's imagine now that we can really measure and plan even before we have these algorithms available. So let's imagine that we are actually in the process of doing this and to transition to the next generation algorithms that we want in our access networks, for example, like the DOCSIS one, which is the broadband one, or OCF or Matter, that are new environments that are coming along. So we need to understand how our networks can really support these new algorithms, which ones can have better performances given the real deployments that we have, and what about how can we plan for device replacement according to our life cycle. For example, it could be 7 or 10 years type of replacements. Let's now imagine that we can define an algorithm X, right, that we could, instead of using security for via signatures and encryption, instead of providing this type of properties, it actually provides, it tries to simulate different type of algorithm characteristics like the memory or the CPU usage and requirements, and collects measurements maybe in the form of signatures. So let's also imagine that we don't have to provide the security together with all these properties. So we can focus on, let's define an algorithm that has the property that we really like. So in this point of view, now, and this is what I call the algorithm X paradigm, where we can imagine about using this composite key that we combine with a real crypto algorithm, so that we keep the security from the real crypto algorithm, and we get all other properties from the second key that we deploy. And we can do this by simply updating the credentials in our devices. So this algorithm X can really simulate different characteristics, as I said, and it can become a really important tool for testing and planning for replacement for hardware. And this is something that can be very, very expensive in some environments. Now, so I hope that I provide you with another use of this composite crypto that really gives you an idea of other possible use in the future of this type of technology that is not just related to post-quantum, but post-quantum is really an interesting use case for us. So coming to the document updates, there's major changes in the draft for the keys, especially following the work group discussion. We added the explicit composite key signature keys. There are 7 new composite signature combinations, and together with 3 different composite CAM combinations, and added the examples for most of them as in the appendixes. One of the important notes is this discussion about should we keep this generic use, this generic mode, or all we need is really the combination of the algorithms. I hope that the example that I provided today really opens up the discussion of maybe there are really more use cases. For example, the explicit one would be when you want to use an algorithm that is not standard. So you have your own deployments, your own data centers, algorithms. They're not standardized, but you can still combine them with a standardized algorithm to maybe get some sort of certification. We try to synchronize the terminology with the draft of Driscoll PQT a hybrid terminology, and we really appreciate the good discussion that's been on the mailing list for all these combinations. Thank you so much. It's been really great. So the other update that we want to bring in, we were not really ready for that, but one of the things that we discussed last time was to remove the OR authentication mode, because felt like it was probably more problematic. So what we did, we actually removed it from the current draft, and we're working on a different document that we're going to submit as soon as possible that basically uses the same type of approach, but defines a new set of OIDs for the keys, reuses the same OIDs for the signatures, but introduces a public key parameter in the composite signature that basically is just an integer that says you need at least k successful validation when you do the validation. This allows you, for example, to achieve the perfect OR authentication mode. If you use k equals 1, k equals n is the same behavior as the current composite, and you can use intermediate cases when you have the 2 out of 3. This is the other use cases that we are pursuing. So the initial is available on GitHub, and we are going to upload it in Data Tracker as soon as possible. So the other announcement here, it was announced on October 26th that there were some patents on another option related to hybrid certificate, and the other option was to use additional keys as encoded in extensions in the certificates. Now, the patents that encumber that type of solution, they've been donated, and I'm not a lawyer, so I'm not endorsing anything. I'm just saying this was the announcement. Please verify for yourself. However, there is a draft, like the draft Truskowski LAMPS PQ hybrid X509, and maybe this could be an occasion to revive also that work that could provide a different type of backward compatibility that is not based on the key, but on an extension. There are some benefits coming from that. As I said before, and I actually also wrote in the chat, my personal point of view is that we really need as many tools as possible to be able to address in different ways our deployments. Now, okay, so John, I don't know if you're there. So do you want to take over for the slides for the hackathon?
So this is John again. So yeah, we had the hackathon. I know we've heard about that before, so you can go to the next slide. So yeah, we had a lot of participants. It was a great time. I think a lot of people had a lot of fun. Go to the next slide. Yeah, so our main goals were to start making use of these new PQ algorithms, also by themselves, but also in combinations with the composites. As Jake mentioned before in the previous presentation, we worked on some of the ASN1 encoding issues. And obviously he's taken that and he put that on the slides. They've taken that into consideration in the draft. So that was one of the goals as well, to give feedback that way. Also to obtain experience using these new algorithms, and also providing an artifact repository for interoperability testing for many different implementations. So you can go to the next slide. Yeah, so we have a GitHub hackathon repository. We kind of defined this artifact format. You can see there, it's just simple object IDs because they don't have the official object IDs yet for these new algorithms. So obviously there's different sets of them being used by different vendors or different people because of need. And this is just an example that we have a different file format for different types like CAs, CRLs, OCSP. We're going to add CMP and others and hope to expand that in the future. We had several, at least at the moment, we have, I think, at least 7 different implementations or providers.
Yeah, I think that there might be 9 now.
Yeah, there's even 9. In the last few days, there's been even more that have come online. So it's great. So we have the GitHub repository. You can check that out. We define that zip structure. The other thing is we have a lot of open source and internal vendor implementation. So we had the OpenSSL developer on there as well. Bouncy Castle, David Hook was there. So it's great to have that range of industry as well as open source and the vendor implementations. And yeah, this was already mentioned by Jake. Actually, looks like he used the same slide. The octet string thing did come up, so I won't mention that. Basically, I think the conclusion is we don't want to have extra encodings of octet strings or that 0004 extra bit. If we don't need them, there's no point. Object IDs need to be flexible at this point. We all know that. We're waiting. Hopefully NIST soon will give us the final OIDs. One thing we did suggest until we actually have those things, we could have an ARC number, a version, because that's the other thing. There are tweaks being made to these algorithms at this time. So to make sure that we can interop and do our testing, we want to make sure we're actually using the same implementation. So that's one way that can be done using OIDs. And yeah, most issues that we found were not related to the PQ algorithms. It was just good old X509 stuff. One thing that isn't there is there was a bit with Falcon. There might be some things to look at because there was a couple little things that came up with that that might need a little bit more looking at, but that's all. So far things have gone really well. And I don't know, was there another slide? I think that was pretty much it. Yeah, so Max, I can turn it over to you.
Oh, okay. Thank you, John. I really thank you for being our champion. Really, the hackathon would not have happened without John. So thank you so much. So just to conclude our little talk, so we think that actually we reach some level of maturity that the work group. It's really we would like the work group to take on this work, especially for the keys and the signatures to be adopted by the work group. We're not ready for the KON, so that's the reason why we extracted that. So we continue to work on separate on the KON, and we hope that this will help the speeding up of the the work group work on this front. Last thing that I would like to ask, and this is a question for the chairs, but really for the whole community, is that as we are progressing this work, which is not just for the composite, but also with PQC certificate. So it's just like a double whammy, right, for us, trying to prove the technology also with the post-quantum. So one of the things that we are noticing is that we are starting to see messages related to implementations, etc. And the question is that appropriate? We would like to share with the whole community, so on the LAMPS workgroup mailing list, but we also aware that we don't want to clutter with implementation oriented type of consideration. So the question for the chairs is, do you think that it's better for us to continue the conversation like we are doing today in the LAMPS? There might be some more conversation related to implementations, or should we set up another mailing list, still a public mailing list, but separate from LAMPS, so that the discussion can progress in parallel? So these are the two questions for the group and for the chairs today.
So does anyone have any comments for Max, and then we'll respond to the his desire for working group chair thoughts. Go ahead, Sean.
Hi, Sean Turner. I'm going to echo a little bit of what DKG said in the Zulip room, what we're calling it now. I'm not so sure that letting 1,000 flowers bloom on a lot of these things is really a good idea. I think it's kind of a, maybe it's just a philosophy thing, and maybe I'm on my little bike shed, but I just don't know if there's really, like, if there's 4 ways to do a certificate. If, like, what do the public CAs think? What are they really going to do? Are there actually protocols that are going to support this? Like, is TLS going to do this? There's a whole bunch of other questions that we'd like to figure out before we just put out a bunch of stuff. Because sometimes when the working group starts to do things, it gets adopted, and then there's just market confusion. And the only thing we're going to do is slow deployment.
Bas Westerman, Cloudflare. I have had the same knee-jerk reaction as Sean. But X509, it's not only used for the web PKI. For the web PKI, I think having this complicated composites is not great, and I think I expect we might not even see signature composites or hybrids at all, just for key agreements. But the web PKI is not the only thing we use X509 for. So if there are convincing applications where this is useful, then I wouldn't be against. But that's not my expertise of other applications.
So hello, this is Markku Jaanisaarinen. So yes, indeed, there are many options here. And this being IETF, what I witnessed at the hackathon was good running code interoperability between half a dozen implementations and such, many people being able to understand the specification for composite signatures as they exist at the moment. So I believe that certainly should go forward. So it's of course not a mandatory thing for people to support, but it is a technology that exists and has been talked over in these meetings for 4 years now. And so in relation to specific proposals, like going back to the Isara thing, no, I wouldn't like that. But personally, it's a minefield still, to be honest. And then these like a little bit more exotic proposals here. Yes, they can, in my mind, they can exist as drafts, but perhaps let's keep them out of the composite RFC of the future. So.
Any other reactions? Okay.
Yes, please. Yes. Well, just one comment. So first, many thanks for the work you made during the hackathon. It's very interesting. And one of the topics you mentioned is the possibility we use Truskowski draft RFC. I would say that it's maybe a very good option for backward compatibility, and maybe it's worth putting it on the table during the discussion, because I think it's an interesting option.
Julian? You're done? Okay. Carl?
On the question about the generic composite, that's mostly what we focused on during the hackathon. I think that should be discussed, perhaps reverting back to that mechanism instead of the explicit composite. You still don't need to let 1,000 flowers bloom. You could define a certain set of algorithms that are supported via this mechanism, but that mechanism is a little more natural to implement support for. And we knocked out several implementations just in the last few days that were interoperable. So I think that's a good argument for the generic composite.
Yeah, so one more thing. So this is a separate issue. This is about the way the composite works, but regarding the sort of extension, non-critical extension, which is potentially proprietary still, I would suggest that that might be something that is an informative RFC that can exist. So those people who want to support this non-critical extension can put together an not a standard track RFC, and that would kind of, people could use it if they want. I mean, it's optional anyway, so that's it.
So if somebody put a non-critical extension, you're talking this K of N, right?
So I'm referring to the ISARA proposal, which was the patent released. So that mechanism works as a non-critical extension in a certificate which contains the post-quantum thing. So this was patented technology. So they released 4 translations of a patent that deals with that specifically. So that previously ISARA refused to release that IP, and that's why it's not there. But that's actually technologically different from like from the composite that we were interop testing already.
Yes. Okay. I now understand your comment.
Hi, I come from the OpenPGP space, but we also been discussing about composite and like the flexibility of composite. And in my opinion, it can easily open up a Pandora vase of combinations to allow generic composite algorithms. And furthermore, even if you restrict the choices, how do you handle those who don't respect these restrictions?
DKG.
So if I may just to answer to the last comment, actually the way that you handle that is built in by using these OIDs and definition for keys and signatures. It's very natural for many protocols to be adapted, exactly as we support RSA or ECDSA or the next type of algorithm. This would be the same type of support. So nothing different than what we do today.
So I just wanted to point out that we can define a mechanism that says, here's how you combine algorithms in a generic way at a software level without embedding the generic composite construction directly into the X509 certificate. When you embed the construction into the certificate wire format itself, you are now pushing all of the implementers to write their own. When they consume a certificate that has this, they now have to have their own complex decision-making process about what kinds of composite mechanisms are actually reasonable and actually make sense. And every implementation is going to choose something different because it's very hard to specify that in a way that everybody's going to just adopt the standard thing. This is a recipe for interoperability failure. If the wire format itself says, okay, here's an OID, and this OID means you use this particular combination, then implementations can choose to support that OID or not support that OID. So you can have the generic composition logic that is not embedded in the wire format. And I think that if you put it into, if you put the generic composition into the wire format, you're going to get a range of certificates that show up with weird combinations, and every implementation is going to have to decide what to do with the combinatorial explosion there of what they receive. And that is a mistake.
Right, DKG, I think that actually I see it very, very differently, the opposite way, in the sense that for us, the combination of the algorithms allows you to have a backward compatibility type of mode. I forgot the point. I'll get back to you later.
John, go
Yeah,
ahead.
I was just going to say, I think the generic and the explicit can coexist. Generic is, we learned from the hackathon too, 2 implementations were born there that use generic. It's not difficult to implement. If people are worried about, you know, the explosion of combinations, I mean, we had there, I mean, that was proof right there. They're able to interop without issue. The explicit one, we took the feedback for that because of the, you know, the comments at the last IETF saying there's, you know, this explosion possibility. So with that one, you do have to basically do the checking to make sure that the OID that you specify lines up with the algorithms you use. So I guess the issue is, I think there's always going to be that, you know, use case out there somewhere where someone wants to use a combination that isn't in that explicit combination. So that's why I think, I mean, I know we've marked it for deprecation or removal of the generic, but I think there's still a use case for that because I don't think we can ever please everybody. So we
Yes,
started with generic because we wanted to have, you know, an option that was open that people could use, but hearing feedback, we went to more explicit. But I think in the real world, I mean, there's always going to be those generic use cases that people might want to use. So that's why it is the way it is. So, but
Yeah,
we're happy to go back to draft 02 if that's what, you know, generic, if that's what people want. But, you know, there's always going to be probably this argument. So.
And John, to complement your argument, so for the generic one, actually, DKG, I think that your argument would be true if we did choose not to reuse the same data structures in a recursive way. So that choice actually prevents us from having really that problem that you say, that the explosion, because it's actually just a sequence of what you already support. So the validation policy is built into the system. So there's actually no choices that this the crypto libraries can really do. Is exactly the same as processing a normal signature today. So that would be my argument against the anti-interoperability as demonstrated in our hackathon results.
Aaron?
So like another point against the using the generic composite is that for instance, for CAMs, you will need to have a key combiner that accounts for all edge cases of putting things together. And in general, you'll also have to worry about like a big matrix. And if you restrict that matrix artificially by saying, hey, you can only do X, then just define those X algorithms. Because if you leave it unrestricted, people are gonna mix weird stuff together because that's what fits them best. And then they're gonna have interoperability issues. And if you don't, and if you do restrict, then you have the same situation as defining them explicitly.
Yeah, I kind of disagree with that in the sense that if you use standard algorithms, you will not have any problems. But if you want to do your specific ones, right, your non-standard ones, you're still allowed. You will not have other clients to validate exactly as if you're not supporting that particular post-quantum algorithm or that particular classic algorithm. So it's not a different way. So the way that you can actually very simply limit what you wanted to accept is, I want to accept this algorithm, not this other one, and you don't support the OID. It's something that we do all the time when we set up our servers. We decide which algorithm we want to support. This is no difference.
Sure. I mean, I was also quite surprised by this working group, like decided to standardize like post-quantum algorithms as a standalone when on the third sentence of the Kuiper website there's written like use it composite. So I already do see some problems there, but this is not my working group. On the other hand, like what is stopping someone from just using the weird combination that might bring to security issues?
Well, these are, if the individual algorithms have some problems, you have bigger problems. So, these are signatures that are we're not changing the way that signatures are performed. Signatures perform exactly the same way. And that's the powerful thing, that the security properties are maintained for each single algorithm. So in many cases, you might decide that one algorithm is sufficient for you, or you want a combination of post-quantums because you don't trust both of them, or you just want to add a classic because, for the next 5 years, you might want to still use your classic algorithm because you validate that that's appropriate. And this is something that one of the things that we are worried about, especially in our environment, is that the replacement of identities, especially in device access networks that we have, many hundreds of millions of devices. That's where we really need to have a plan for the long term. And actually, what we're trying to do is maybe whenever we in the future we have an algorithm that doesn't provide with all the characteristics that we want, we might just add these characteristics by replacing the identity of that device, issuing a new certificate. That's all we need to do to actually add this new property. Of course, given that you have software updates and you can update the algorithms, etc. So it's kind of like a long-term view that we're trying to bring here, not just for a single instance.
Yeah,
if that makes sense.
All of this makes sense. My problem with your statement was when you said the user might want to use ECC composite. I think a user should use or must use ECC composite as of now, because we have seen what happened recently with Psych, or like it might happen to Kuiper too.
Yeah. Thank you.
Okay, John, you're the last one.
Yeah, I know our time is getting in. I was just going to mention chem was mentioned, so we do have a draft for composite chem as well. There wasn't really any updates this time for it, but the big thing for that one is we do have the question on the key combiners. That's why we made it flexible in that draft. So if we're still looking for feedback on that. Obviously, the trivial XOR is, what we thought you would have to do, but then we started reading papers and it gets into a quagmire. So if anyone can have I don't know, maybe that's an IFRG discussion or whatever, but anyway, so there's a composite chem draft, and the key combiners is kind of the big discussion on that one.
Okay, so what I think the working group way forward here is you've gotten all kinds of advice here about different approaches to from generic to nailing down. I don't know which one the authors want to advocate at this point. I'd like to see some discussion of that on the list, and then an update to the draft, and then we'll do a call for adoption to see if you found a sweet spot. Does it make sense? Okay. We have one more presentation on hash-based signatures and X509.
Hi, can you hear me well?
Yes. Did you send slides?
No, I didn't. I just wanted to quickly announce that we just published an internet draft. It's kind of an early version. I can just share the draft if you want. Can I share my screen?
Yep.
Okay, great. So you should now see my screen. So it's basically an early version of an internet draft that we want to bring forward. And it's based on some previous work by Scott Plura and Daniel van Geest. And it's because we've talked to quite a lot of people lately who want to actually use hash-based signatures in X509. And it's mostly for having like a root CA for the PKI. So we're talking about some secure key server or some HSM. So some means of secure key management on the root level. And they want to use hash-based signatures as like the quantum safe alternative for the classical schemes. And they want to use it for the root CA because you can trust hash-based signatures right now, while they don't really, well, they aren't sure what to use on the levels below. So on the levels below, for example, of course, you could like use dilithium or something, but they want to have like this real secure root CA. And that's why we want to bring this forward. So it's some sketches that we made, and don't be scared of what we did so far. For example, we used ASN1 sequences for the data structures because we wanted to show the differences in the different schemes that we provide here. And that's nothing we have hard feelings about. But the problem is there's like a lot of hash-based signatures right now. There's LMS and HSS. There's also XMSS and XMSS-MT, which are defined by RFCs already by the CFRG group. Then there's the stateless Sphinx Plus in the NIST process. There's a new scheme called Pyramid that is quite promising, that overcomes some issues between XMSS and Sphinx Plus, which means you could have like one scheme with a very small verifier for a stateless scheme as well as a stateful scheme. And they're quite similar, but still there's a lot of difference in the details. And we wanted to have one document where we can have like a more unified nomenclature, so more unified naming, and also providing like information about the differences. So making an implementer's life easier in order to show if you want to use this signature scheme, you have to do this, and for the other one, you have to do that. And there's quite some interest because we've talked to people from agencies who have to provide like PKI for national agencies. We've talked to trust centers, but also to some people from industry. And we are interested if LAMPS is interested in picking something up like this. And if you have any other needs for like any other use cases, and of course, please feel free to have a look at it. Please tell us your opinions. As I said, it's like more like a sketch right now. We don't have too hard feelings about the content. We will extend it, for example, with information about what not to do with your private key or how to handle your private key securely. There's some more references we want to include, but in short, the idea is to have like one content about hash-based signatures in X509 for all those relevant schemes out there, because we also know that there's some people who prefer like LMS, there's other that want to settle for XMS, so we think those schemes will stick. And I'd welcome any feedback. So thank you very much.
Okay, so one thing is we have a draft on using these XMS LMS, I'm sorry, HSS LMS in CMS, and it would be really important to me that the signatures you're using in CMS are the same as the ones that are there for CMS are the same as the ones you're using in X509 environment. We have 2 people in the queue. We have 2 minutes left, so I'm going to let them speak, but then we'll close the queue. So, Jonathan?
Yeah, Jonathan Hamill. So I was going to say the same thing, that RFC 8708, I think it is, the HSS or LMS in CMS has a specification for public keys, which I think is incompatible with how you've specified it in your draft. So I think there needs to be alignment there.
Okay.
Okay, Henrik Brockhaus, Siemens. Stefan, you have a draft on XMSS. There was an errata on the specification of the key formats. Are there any plans to update the document?
Yeah, we hope to update it soon. There's were again some questions that we wanted to clarify first. It's like an issue that's taking quite some time right now, and I'm sorry about that. But there's like other changes that are supposed to come for XMSS, and that's what we wanted to clarify first. But hope that the XDR stuff will be clarified soon. So there will be an errata, yes.
Okay, thanks.
Okay, thank you. That brings us to the end of our agenda and the end of our time. So thank you very much to the note takers, Alexei and Carl, and thank you for all your participation. Have a great day. Just leave it in the notepad.
Thank you.
Yes, that's true. I'll grab it shortly.